Please, if you are active, indicate that you are active. If you are active, indicate that you are active. Good evening, everyone. If you are active, please indicate that you are active. If you are active, please indicate that you are active. If you are active, please indicate that you are active. If you are active, please indicate that you are active. If you are active, please indicate so we can start, okay? Please, for those of you who just joined us, who just came online, please do me a favor to share the link. Share the link to your various departmental platforms. Please share the link, share the link, share the link, share the link. If you have shared the link, let me know from the comment section. Please share the link, share the link, share the link. Let's keep sharing the link. If you have shared the link, please indicate that you have shared. All right, we are starting right away. We are starting right away. This night we shall be looking at mathematics, and our emphasis will be on various topics in mathematics, because this is an exam preparation class. So we'll be solving different questions in mathematics, and take note that everything I'll be dealing with tonight, 80% of them will attend in the exam. Not just tonight, throughout this period. Any topic, anything I'm teaching or we are solving in mathematics, from now to exam period, will surely appear in your exam. It will appear in your exam. All right. So we're looking at a series of topics in mathematics. We might not be able to exhaust every topic tonight, but definitely we will touch some major aspects in Math 101. All right. So please share the link. If you have joined us, please share the link. 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 Comment. Let me know that you are active. Just comment. Put down your comment in the comment section. Write something that you have joined. You are active. Let's know those who are online. All right. Okay, the first aspect we're going to look at is the aspect of set theory, the aspect of sets. We'll solve a problem. We are looking at 2021 past question first. 2021 slash 2022. Okay? We'll look at some topics. We're going to look at past question first. Okay, under sets. Now, the first question we have here, under set. By now, we all know what is a set. Set is a collection of well-defined objects. We have solved, I did a full video on set, but I was unable to conclude on it because of time frame. You can always go back to the first class we had in mathematics on set theory. But I want us to look at series of questions under sets. Once we are done, we move into other aspects like binary operations and the rest. Okay, here we are told that the first question says, let A difference B be equals to A minus B union B minus what? Minus A. Please, if you are active, indicate your presence. Please, if you are active, indicate your presence. If you are active, indicate your presence. Please comment and share the link. Share the link. Share the link. Share the link. Share. Please, let's share. Don't just join. If you have shared the link, let me know in the comment section. Let me know from the comment section if you have shared the link. If you have shared the link, please indicate from the comment section. Okay, let's continue. Now we have told that A difference B. We call it symmetry difference under set theory. That A difference B is defined as A minus B union B minus A. This means symmetry difference in sets, and this means A difference B union B difference what A. That's what symmetry difference. Okay. Now, A difference B means those elements that are found in what? In A, but not found in what? In B. B difference A means element found in what? In B, but not found in A. And we are told that set A or subset A is given as 1, 3, 5, 7, and 9. Subset B is given as 2, 4, 6, 8, and 10. And subset C is given as 1, 4, 7, and 10. Then we also find number 1. The first question says, the first question says find A difference B union A difference C. That's the first question. Okay, that's just the question we are asked to find. Now, let's look at this question under set. We are told that if symmetric difference between A and B is defined as this, right? And we are told that subset A is this, subset B is this, subset C is given as this. Then we also find symmetric difference between A and B union that of what? A and what? And C. Already we have been told that between A and B is A minus B union B minus A. But we are not given that of A operation or A difference or C. We don't know the symmetric difference between A and C. So we can from here define that of A and C. If A and B is A minus B union B minus A, that means between A and C will then be A minus C union C minus what? A. Now what do we do first is that we are going to look for, have to look for A difference B. To find symmetric difference between A and B, right? Which we all know to be what? A difference B union what? B difference what? A. I have to solve for this first. After getting for this, I will now find this, then get their union. I hope that is clear. But let's look for A difference what B. A difference B simply means what are the elements that are found in A, but not in what? In B, right? Element found in A, but not in B. 1, 3, 5, 7, 9. They are all in A, but not in B. So that means that those elements that are found in A, but not in B, are simply what? Element of what? Of A. All these elements are in A, but they are not found here. So that means I'm going to repeat. We have 1, we have 3, we have 5, we have 7, and we have what? 9. For that of B difference what? A. This means element found in B, but not in what? In A, right? 2, 4, 6, 8, and 10. They are all in B, but not in A. That means our B difference A is simply what? All a set of elements in what? In B, which is 2, 4, 6, 8, and what? And 10. Now what do we do next? Is to find symmetric difference between what? A and what? And B. Therefore, okay, let me come here. Therefore, A difference B, which is, or we can say recall that A difference B is what? A minus B, union what? B minus A. This means symmetric difference between A and B. So what we do is to find their union. Don't forget that we are asked to find symmetric difference between A and B, union that of between what? A and C. What we are doing now is to define this first. And we are told that this is defined as this. So what we did first was to find this, right? That gave us this. Then find this. That gave us what? This. Then what do we do? To find this, I have to find their union, right? So let's go. Therefore, symmetric difference between A and B will then be what? It simply means union means we are combining these two sets without repeating any element. So the result is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means from 1, 2, 3, 4, 5, dot, dot, dot to what? To 10. So A difference B is simply numbers from 1 to what? To 10. Now the next thing is to find symmetric difference between A and what? C. Also, A difference C. What do you think that will be? If the symmetric difference between A and B is A minus B, union B minus B, no, B minus what? A. What do you think will not be the symmetric difference between A and what? C? That will be what? A minus C, right? Union what? C minus what? Minus A. Now, to solve for this, it means I have to find what first? I have to find A difference C. And A difference C simply means those elements that are found in A, but not in C, right? Element found in A, but not in C. Let's take 1 is in A, also in C. So 1 is not part of the elements. We have 3 here, but there's no 3, right? So the first element is 3. Let's confirm for 5. We have 5 here, okay? But there's no 5. The next is 5. We have 7. There is 7, so we don't need 7, right? We have 9. There's no 9. So we have 3, 5, and 9. A difference B. Element found in A, but not in C. Element found in A, but not in C. 1 and 7 are in A. They're also in C, so we don't need them. So we only need 3, 5, and 9, which is this, right? Now the next is to find C minus what? A, or C difference A. This means those elements that are found in C, but not in A. Element found in C, but not in A. 1 and 7 are in what? Are in C, right? They are also in what? In A. So I don't need them. So the elements we are looking for is 4 and 10. Because 4 and 10, they are in C, but not in A. So the result here is 4, comma what? 10. Therefore, let's find A, symmetric difference between A and what? C will then be the union of A difference C and what? C difference A. Meaning I will combine these two together, right? And that will give us what? That will give us 3, 4, 5, 3, 4, 5, 9, and what? And 10. So I've been able to solve for symmetric difference between A and B, and that of what? A and C. Between A and B, we find out that the numbers are what? From 1 to what? To 10. Between A and C is what? 3, 4, 5, 9, and 10. But the question said, find the symmetric difference, the union of the what? Symmetric difference between A and B and what? A and what? And C. Meaning, I'm going to look for the union of this with that of what? This, right? Union means combination of these two without repeating what? Any element. Is that clear? So let's find their union. Therefore, symmetric difference between A and B, union between A and C, is simply the list of elements. By the time we combine them, what we have 1, 2, 3, 4, 5, 6, 7, 8, down to what? 10. Union means we are combining the two subsets without repeating any elements. That will give us 1, 2, 3, 4, 5, 6, 7, 8, 9, and what? And 10. This is the final answer for this question. The next question, please, if you are following, indicate that you are following. Please indicate that you are following. The next question. The next question. Still under sets. Let's look at few questions under sets. Question number 2 says, in a class of 32 students, please take note of this question. In a class of 32 students, a student can either do a course in physics or biology or both. If 16 students do physics, 18 do biology, and 3 none of the courses, find how many students that do both. This is practically a set problem, and it involves Venn diagram. Here we are given 2 different subsets, which is what? Either physics or what? Or biology, right? But we are told that the total number of people in the class is what? They are 32. So universal set is what? 32. Those that offers physics, which is P. Physics. 16 offers physics. Okay? Then those that offers biology, 18 for biology. B is what? 18. Okay. We're not told that 3 offers none of this course. Meaning none means number of, or rather, none simply means physics union biology, all what? All prime. Or number of physics union what? Biology all prime. Meaning they are not part of either physics or biology. They are just inside the world, the general set. Now let's draw this diagram, then we'll solve. Here we are asked to, question then says, right? Question then says that How many students offers both what? Subjects. How many students offers both? The first question says how many offers what? Both. Let me add some other question to it to make up this so I can just teach. The first is how many students offers both subjects. Number two, exactly how many students offer both? Exactly how many students offers? Number two, how many students offers exactly one subject? Number three, how many students offers exactly two subjects? Two subjects. Number four, how many students offers at least one subject? Number five, how many offers at most one subject? All right. So we are told that our general set is what? Is 32. Those that offers physics, so we have two subsets here. We have physics and we have what? Biology. For physics, we have 16. Biology, we have what? 18. Are you there? Those that offers neither physics or biology, we are told there are many in number. Sorry, I didn't put the number there. There are three that offers none. Three. So they are somewhere outside. Are you there? Look at this. This subset here represents physics. This represents what? Biology. Right? The intersection represents those that offers what? Both subjects. So we call it what? X. We call it X. Because we don't know the number of those that offers what? Both. And we're asked to find it. So let's call it what? X. This other space here you are seeing here is called physics only. This part is called what? Biology what? Only. The entire set here represents physics. For the fact that 16 offers physics does not mean that only 16 offers what? Physics. It means that there are also some persons among these 16 that also offers what? Biology. From here, because there's an intersection here. For the fact that we are told that 18 offers what? Biology, does not mean that only 18 offers biology. It also means that there are some persons among these 18 that also offers what? Physics. Now what do? Is to find what we call physics only and biology only. Physics only means those that offers physics only physics will be 16 minus what? X. Because if the entire circle here is 16 and I'm removing a fraction of that 16, it means that the remaining part will be what? 16 minus X. For example, let me give an illustration. If from here to here, for instance now, is 10. It's 10 meters. And I remove this fraction, which is X. Or let's say this fraction is what? Is 3. If from here to here is 10 and here is 3, what will be here? Is 10 minus what? 10 minus 3, which is what? 7. Abi? So that 7 plus 3 will now give us what? 10. So that means that if I'm calling here X, and I'm saying that the total length here is what? Is 10. Right? What will be here is what? 10 minus what? X. The same thing will also give here. If the entire circle is what? 16. And X is the intersection. To find here, what do? 16 minus X. What about this part here? Here will be 18 minus what? X. So for physics only, we have 16 minus X. For biology only, we have 18 minus X. Okay? Please pay attention. Now the next is to find X. How do we find X? We have to add up all these numbers here in the set, in the subset. I will add up 16 minus s plus 18 minus s plus 3. Meaning I'm adding exactly 1, which is physics only, plus biology only, plus physics and what? Biology, right? Then plus what? 3. These 18 and 16, they are not part of the set anymore because I've been able to define them using what? My subsets. Is that clear? So why adding? I will not add 16 and 18. I'm only adding this, and what? 3. Okay. Number 1 says how many, right? Offers what? Both. For both, what do we do? We have to add up 16 minus what? X plus x. 16 minus x plus 18 minus x plus 3. All equals to the sum of all of these sets here. This is to what? 32. Because we are told that general set is what? 32. All equals to 31. So what we do next is to find the value of x. But let's take this out. Minus s plus s is 0. These two will cancel out, right? This will go with what? With this. Are you there? This will go with this. We are left with what here? Minus what? Minus x. Please, I hope you guys are following. If you're not getting what I'm saying, please indicate in the comment section if you are not getting it. Can we proceed? Can we continue? Are you guys following? Are you guys following? If you are following, please indicate in the comment section. Indicate. So we can continue. Okay, someone start to write on. Now let's add up. 16 plus 18 is about 34. Abi? 34 plus 3 is what? 37. Is that clear? All equals to what? 32. The next is to move this 37 across, Abi, or we subtract 37 from both sides. Is that clear? And that will give us what? Yeah? Minus x equals to what? 32 minus what? 37. And that will give us minus x is equals to, when you subtract these two, what we have is minus what? 5. Is that clear? So that will give us, from here, minus can cancel minus, right? Or we divide both sides by what? By what? By minus 1. That means our x is equals to what? 5. So that means that 5 offers both what? Both subjects. 5 offers both subjects. 5 offers both what? Subjects. Okay, let's proceed. The next question says, how many offers exactly one? Exactly what? One subject. How many offers exactly one subject? Number 2 says exactly 1. What is exactly 1? Meaning 1 only. This is exactly 1. This is exactly 1. Are you there? It means I'm going to add up this plus what? Plus this. If they said how many offers physics only, the answer is what? 16 minus s, meaning 16 minus 5, Abi? And that will give us what? 11. But if they say biology only, what's the result? 18 minus s. But if they say exactly 1, it means I will add up this and this together. Now let's see what we're going to have here. That will give us 16 minus x plus 18 minus x. Already our s is 5. That means 16 minus 5 plus 18 minus 5. So yeah, we're going to have here to be 11 plus 18 minus 5 is about 13. So the total answer here is what? 24. Please, if you are following, indicate in the comment section that you are following. Next question says, Next one says, how many offers exactly 2? Exactly 2. I've already mentioned the answer, right? Let me just solve it here. So we call for exactly 2. Exactly 2 means X. This is exactly 2. Meaning those that offers physics and what? Biology only. The answer here is X, which is equal to what? 5. Abi? So this is same as how many that offers both what? Subjects. Then the next question says, how many offers at least 1? How many offers at least 1? What is at least 1? Let me explain. At least simply means, at least 1 means those that offers 1 or 2 or 3 or 4 or 5. But in this case here, we have just 2 subjects. So when I say how many offers at least 1 subject, meaning the list must be 1, followed by what? 2, followed by what? 3. Now the result simply means at least 1 subject. Number 4, at least 1. This simply means those, right? This is the sum of exactly what? 1 plus exactly 2. At least 1 means those that offers 1 subject, meaning exactly 1 subject plus exactly what? 2. If I have a third subset, let's say I have a diagram here, it simply means I'm going to add plus exactly what? 3. At least 1 means either 1 or 2 or 3. But if they say at most 1, it means I'm coming below. Meaning the highest I can get to is what? Is 1. Followed by what? 0. Meaning at most 1 means those that offers exactly 1 and those that offers none. And where does none fall in? 3. But let's solve this first for at least 1. This is the sum of exactly 1 plus exactly 2. What do we solve as exactly 1? Is 24, Abi? This is exactly 1. What is our exactly 2? The answer is what? Is 5. So total answer becomes what here? 29. The next one says, how many offers at most 1 subject? At most 1 subject. At most 1 subject. Number 5. At most 1, I've already explained, meaning I'm going down, right? Those are offers. This is the sum of exactly what? 1 plus what? None. Plus none. Meaning from 1, 0. If they say exactly 2, meaning those that offer exactly 2 plus exactly 1 plus what? None. If they say exactly 3, that means, so if they say at most, rather, at most 3. At most 3 means those that offers exactly 3, exactly 2, exactly 1, or none. At most 2 means those that offers exactly 2, exactly 1, and none. But the word at least 1 means those that offer exactly 1, exactly 2, exactly 3. If I have 3 subsets, I will have to include what? Exactly 3. Exactly. So let's go. So at most 1 means sum of exactly 1 plus none. Exactly 1 is what? Is 24. Plus none is what? None means those that did not offer neither physics or biology. The answer is 3. So the sum of this is what? Summary 27. We are done with this part of sets. Let's move down to the next question. Please, if you are following, indicate in the comments section. Please indicate in the comment section if you are following. Indicate in the comment section. All right, let's look for another question. I think in the past question and discuss about it. The next question here says, under set, the subset A and B, the subset A and B, the subset A and B of a universal set are defined as follows. Universal set given, this was given in set builder, was given, we have X such that 10 is less than X, less than or equals to 30. And we are told that set A is X such that X is a prime number. Then set B is given as X such that X is an odd number. Then set C is X is such that X is a multiple of 3. Then the question says list. The first one says list the elements. Of I, A, I, B, I, C, IV, A intersection C, V, B intersection C. Then the second question says, this is question A. Question B now says that describe set what? Set D equals to 11, 13, 17, 19, 23, and 29. Okay, sorry. In terms of set A and B, in terms of set what? A and what? And B. All right, let's look at these questions together. This is your past question. Okay, are you guys following? This is your past question. This is a past question. We are told that universal set is given as x such that 10 is less than, let me confirm, less than or equal to, equals to what, x, less than or equals to what, 20. Okay? 20. Is that clear? And set A is s such that s is a prime number. Set B is s such that s is an odd number. Set C is s such that s is a multiple of what? Of 3. Then the question says, list the element of what? Of A, B, C, A intersection C, B intersection C. Then describe set D, which is this in terms of set A and set B. Now, what we do first is that before we list the element of A, B, and C. The A, B, and C, they are called subsets. Subset of the general set. I cannot list the element of A, B, and C without describing first this general set. I have to uncode this. This is called set builder, right? I have to bring out all the elements here in this set builder. And here we are told that f is such that 10 is less than or equal to what? X. If 10 is less than or equals to x, right? That same x is less than or equals to what? 30. If 10 is less than or equals to x, that also means that this x here is greater than or equals to what? 10. Hope you are aware. If 10 is less than or equals to x, the reverse of this statement is what? X is greater than or equals to 10. You now ask yourself, what are the numbers greater than 10 with 10 inclusive? Because here we have equal sign here. It means if I'm to list out all the numbers greater than 10 or equals to 10, I have to include what? 10. So the number greater than or equals to 10 simply means from 10, abi? Followed by what? 11. Followed by what? 12. Followed by what? 13. I will keep on listing until I get to what? 30. Why do we have to stop at 30? Because we are also told that that same x is also less than or equals to what? 30. Meaning I will start from 10 and end where? At 30. But if the question says x, 10, is less than x, the reverse of this becomes what? X is greater than what? 10. It means if I'm to bring a number greater than 10, I will not include what? 10 again. Because there's no equal sign here. But because we are told that this 10 is less than or equals to what? X. In return, that means x is greater than what? Or equals to 10. That means I have to include 10 because we have an equal sign. Then on this other end here, because I have an equal sign that same x is less than or equal to 30. It simply means that I will start from 10 and end where? At 30. But if there's no equal sign here, it means I will stop at what? 20 what? 29. Because 30 is not part of the number. But because we are told that this is an equal sign, less than or equal to 30, it means I will stop at what? At 30. So before we start solving it, I have to bring out all the elements in what? In the general set. Okay. Okay? Recall that general set here is simply what? Let's list out all the elements. We have from 10, we have 11, we have 12, we have 13, we have 14, we have 15, to what? To 30, right? Please, in the example, try as much as you can to list out all the elements. I know it will look somehow boring, right? But try as much as you can to list them out. Now listen. The next question now says, this list the element of A. The element of A, we are told that A is that S is such that S is a prime number. What are prime numbers? These are numbers that have two divisors, 1 and itself. Is that clear? 1 and itself. An example of a prime number. 1 is not a prime number. 2 is a prime number because 2 can only divide itself and 1. 3 is a prime number because 3 can divide itself and 1. 4 is not a prime number. Why is 4 not a prime number? 4 can divide itself, right? 4 can divide 1. 4 can also divide 2. Okay? So 4 is not a prime number. Numbers that have only two divisors are called prime number. Like 2, for example. 2 can only divide itself. I mean, also what? Also 1. To give us a whole number. I hope you are aware. 3 is the same thing. But 4 cannot. 4 is not a prime number. So if 4 is not a prime number, what then is 4? 4 is simply called composite number. If a number is not called prime, it simply means it is called a composite number. Meaning they have either 3 or more than what? 2 divisors. They have more than 2 divisors. Alright? Okay. So, but if I'm to list all the elements of A, I should not exceed this. A is a prime number. I will now ask myself, from 10 to 30, what are the what? Prime numbers you can locate here. What are the prime numbers you can locate here? Is that clear? That is how to list out A, because I can't start by putting 2, 3, 4, 2, 3, 5, because 2, 3 are not in the general set. General set is that set that houses every other subset. So every set, A, B, C, must be located, must be found here. There must be a subset. A, B, C are what? Subset of the general set. That means they are part of the general set. They are part. They must be part of the general set. Now let's list them out. 10 is not part, Abi. 10 is not a prime number because 10 can divide itself. 10 can divide what? 5. 10 can divide what? 2. 10 can even divide 1. So it's not a prime number. So what of 11? 11 is a prime number because 11 can only divide itself and what? And 1, right? And 1. By now you should know what prime numbers are. So I'm going to list them out. Numbers, the first is 11, right? Followed by what? 13. 12 is not. 13 is a prime number. 14 is not. 15 is not. 16 is not. But 17 is a prime number, right? Followed by 18 is not. 19 is a prime number, right? 20 is not. 21 is not. 22 is not a prime number. The next is what? 3, right? Followed by what? 24 is not. 25 is not a prime number. 26, no. 27, no. 27, no. 28, no. 29. The next is what? 29. Is 30 a prime number? No. So I will not include what? 30. So these are the elements of what? A. We have been able to solve for question A. Question B now says that I says B is an odd number. Odd. By now we know what are odd numbers, right? Odd numbers. What are the odd numbers here? The first, 11. Sorry, from here. 10 is even. 11 is what? Odd, right? 12 is even. 13 is odd. 14 is even. We have 15. We have 17. We have 19. We have 21. We have 23. We have 27. And we have 29. So these are prime numbers. Don't forget that these numbers must be within the general word set. Okay. The next one says numbers that are multiple of what? 3. Multiple of 3. I. Multiple of 3. C. Multiple of what? Of 3. Okay? Meaning that numbers that I can multiply, I can divide by 3. Are you there? The first one is what? I can divide 10 by 3. I can't divide 11 by 3. I can divide 12 by 3. So 12 is a multiple, comma, followed by 15 is a multiple. After 12, we have 13. 13 is not a multiple of 3. 14 is not, but 15 is. Number that we can divide by 3 are what? Multiples of 3. So 12, 15, followed by 21, followed by 24, followed by 27, followed by what? 30 itself is a multiple of 3. So we have solved A, B, and what? And C, right? The next question says find A intersection what? B. A intersection B. What is the meaning of the word intersection? Meaning between A and B, what are the common elements? What are the common elements between A and B? Let's take them together. 11, 13, right? We have 11. We have 13. Okay. 17, no. 19, yes. We have 19. 23. We have 23. Okay. 29. We have 29. So these are the common element between A and what? And B. A and B. Between A and B. We have between A and B. Okay. Okay, the question actually say between A and C, but let me just take it that way. The question say between A and C, right? I solve between A and B. Now let's solve the main question itself. Sorry for the mistake. Between A and C. Between A and C, is there anything common? Let's find out. We have 11, we have 13 here. 11, no 11, 13, no 13, 17, no 17, 19, no 19, 23, no 23, 29, no 29. So the answer is what? Is an empty set, right? Or a null set, meaning there is no common element between A and C. Either. What does this mean? It means that set A and set B are disjoint sets. Two sets are said to be disjoint if their intersection is an empty set. So since there is no common element between them, it means that set A and C are what? Disjoint. Okay? The next says what? B intersection what? B intersection C. B intersection C. Let's find out between B and C. We have 11, it's not here. We have 13, it's not here. We have 15, 15 is here. So 15, 1. We have 17 here, it's not here. We have 19, 19 is not here. We have 21, but it's not here. We have 23, it is not here. We have 27 here. So 15 and 27 are the common element between them. 15 and what? 27. 15 and 27. Between B and C. Between B and C. Between B and C. Right? Between B and C. Let's check again. There's 21 in both. Sorry. 21 and 27. 21 and what? 27. Okay? Between B and C, we have 15, 21, and 27. Don't forget. Now the next one says, please write. Are you guys following? Now we are now to describe set D in terms of A and B. Describe set D in terms of what? A and B. Yes, I've noticed, I've put it. Thank you. 25 is not among. 25 is not among. For which one, please, indicate. For which one? Someone said 25 is not among. Among which one? Okay, let me verify something. Set B We are told that set B is what? An odd number. Odd number. Thank you. Odd numbers there are what? 21, 23. We are meant to have 25, Abby. Thank you. 25. Please include 25. That is an error from my own side for B. We have 21, 23. 25 is an odd number. So I've included it. Let's take again. Prime numbers. Okay, this is correct. What about set C? Set C, multiples of what? Of 3. 12, 15, 21, 24, 27, 30. Okay, is there another one again? Please, if you are following, please indicate in the comment section. Sir, you have missed 18 in set C. You have missed 18 in set C. 18 in set C. Thank you, thank you, thank you. Set C. Set C. After 15, we have 18. Thank you, thank you. The multiple, we have what here? We have 18. Thank you. Multiple simply means numbers we can divide by 3 and without any remainder. So 12, 15, 18, 21, 24, 27, and 30. Thank you so much for that observation. That means you guys are following. All right? Please, I need your comment in the comment section. Please, your comment in the comment section. Your comment, your comment, your comment. Your comments. I'm still observing the question. Are you guys following? Okay, so let's write on. Now listen. The next question then say that. The next one say that we should describe set D in terms of set A and set B. In terms of set A and set B. Now let's look at in terms of set what? Set A. I want to describe set D in terms of set what? Set A. What is our set A? Set A is what? 11, 13, 17, 19, 23, and what? 29. What do you notice here? Now all the elements in set D are also in what? In set A. So in terms, how do we describe this now? Is that in terms of set A, we are saying that set A is equals to what? To D. What are equal sets? Equal sets are those sets that have the same element in common. That is, elements in the first set are the same element in the what? In the other what? Other sets. Is that clear? Also, number one, here we have A is equals to D. This also means that A is a subset of what? Of D. Right? A is a subset of D. Also, D is a subset of what? Of A. Let me describe this first. If A is equals to D, that means D is equals to what? To A, right? Since every element in A are in D, and every element in A are in D, right? Or D are in A, this also means that, so this is my letter D, this also means that A is a subset of what? Of D. And D is a subset of what? Of A. That is the first one. Then in terms of B, please, are you guys, have you taken note of this? Please, take note of this. Every element here are also in what? In A. It means that A and D are both equal. And also A is a subset of what? Of D. D is also what? A subset of what? Of A. You know, last class, we learned about subset and proper subset, right? I will say that we have two conditions for subsets. The condition is that the value of A should be equals to B, or the value of what? A is not equals to what? To B. We go through that class. We did a class on subsets and proper subsets, even down to supersets and super proper sets. Please go back to that class. That for subsets, we have two symbols. This means subset. This means what? Proper subset. For subset, if between two sets A and B, it means that set A is equals to B, right? Or set A is not equals to B. That's for this subset. But for proper subset, this has only one condition, which is what? A is not equals to what? B. So since our A and D are both equal, so the right language to use is what? That A is a subset of D, or D is a subset of A, because this satisfies the first condition for what? For subset. Please go through that class. It will really help you a lot. Now let's describe D in terms of what now? B. Let me clean this in terms of B. In terms of B. Let's look at this here. In terms of B, we have 11, 13, 17, 19, 23, and 29. Let's find out if all these elements are also here. We have 11, 13, 17. 11, 13, 17, right? We have 19, right? We have 19. We have 23. We have 23. We also have a 29. We have a 29. In this case here, what do you notice is that every element in D are found what? In what? In B, right? They are found in B. That means that, but D and B are not equal. Listen. Since D and B are not equal, that means that this relationship here between D and what? And B, I can either use what? Subset or proper subset to describe them. Because for subset, we have two conditions. It's either A is equals to B or A is not equals to B. But for proper subset, we have just one condition, which is what? A is not equals to what? To B. Am I communicating here? So for here, in terms of what now? Set B, right? I'm going to say that D is not equals to what? To B. Now, that is the first one. I can also say that set D is a subset of what? Of B. Right? I can also say that set D is also a proper subset of what? Of B. But D is not equal. Okay? This is called subset. This sign here, you are seeing here, this dash means what? An equal sign. Because there's no equal sign here, this means what? Not equals to. Don't forget. This means not equals to. This means what? Equals to or not equals to. So that means I can say that since my D is not equals to B, that means I can either use this symbol or this symbol. Because in this symbol, we have A not equals to B. In this symbol, we also have what? A not equals to what? To B. So the description of this is this. Take notes. All right? Please, if you are following, indicate that you are following. Indicate that you are following. Indicate, 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 indicate. Please indicate that you are following. All right. The next topic I want us to look at is what we call mathematical induction. And I'll be brief about this. Mathematical induction. Mathematical induction. Now, when you hear the word mathematical induction in mathematics, you have to pay attention to this class. This topic is kind of confusing, but it's very simple. I will try as much as I can to explain this to the lowest, to the simplest possible way. Are you there? So please, if you are following, indicate that you are following. Are you guys following? Please indicate that you are following. If you are following, indicate that you are following. If you are following, please indicate your presence. If you are following, please indicate your presence. If you are following, please indicate your presence. If you are following, please indicate that you are following. Okay. Now let's move on. When you hear the word mathematical induction, I will just explain briefly that I will move on, okay? Mathematical induction is just a powerful proof technique in using mathematics to prove that a statement or a formula is true for all natural numbers. All right? I say that mathematical induction is a powerful proof technique using mathematics to prove that a statement or a formula or any algebraic is true for all what natural what number. And in mathematical induction, we have two powerful steps. We have two powerful steps using proving formulas. The first step is called the base case. Number two is called inductive steps. Inductive steps. Okay? In the base case, we are testing for n equals to 1 or n equals to 2. I call this a test for natural numbers. I call this a test for what? Natural numbers. Meaning I'm testing for the position of each of the terms. Each of the terms in a mathematical statement. I will give an example, then we'll see how to solve this. Then we'll also look at your past questions and all that. But the first step is a test called what? The base case. Number two is called the inductive steps. In the inductive step, we are testing for two things. We are testing for n equals to k and n equals to what? K plus 1. N equals to k is called the last term. N equals to k plus 1 means the succeeding term after what? K. Let's say, for example, if I have 1 plus 2 plus 3 plus 4 plus ... let's say I have it to the n equals to n plus 3 over 2. I'm just assuming. Here we have how many terms here? 1, 2, 3, 4. 4 terms. From this point here, this I call the base what? The base case. Meaning I'm testing for the position of each of these terms. I'm testing for n equals to 1, n equals to 2, n equals to 3. This can also be, let's say we have 1 square plus 2 square plus 3 square plus what? 4 square. Okay? To test means, to start with the base case means we are testing for the natural numbers. The natural numbers, n equals to 1, equals to 2, equals to 3, equals to 4, and all that. Now, when you test, the test here means every term you have on this side, on the left-hand side, must be equals to what? The right-hand side. Just like under dimensional analysis, when we are proving formulas, to prove that the formula is correct, is that when all the terms on the left-hand side is the same as what on the right-hand side. This is the same thing here. I'm going to show us the steps. We apply the base case, then we go into the inductive step. Now, look at this. Let's say I have 1 plus 2 plus 3 plus 4, the initial one I gave. If I'm to add 1 to 1, that will give us 2. When you add 1 to 2, we have what? 3. When you add 1 to 3, we have what? 4. Let's say if the last term is what? Is k. Are you there? Since addition of 1 gave us the succeeding term, if k is the last term, what will be the next term after k? Is k plus what? 1. If adding 1 will give us the succeeding, the next term, and if our k is the last term, if k is the last term, that means the next term after k is what? K plus 1. This is where the concept called inductive steps comes in. And there's somebody. Now, let me just go straight to the point so that we can just, I don't want to spend much time on this. I'm not trying to break this down in a way that you understand what I mean by that. Okay, let's solve a problem now. Let's solve a problem now. If we are asked to prove that the statement below is true for all natural numbers. What is statement? We are told that we are given that Sn equals to 1 plus 2 plus 3 plus plus n equals n in brackets n plus 1 over 2. N plus 1 over 2. This statement was given to us, but we are asked to prove the statement if it's true for all natural numbers using what mathematical induction. Are you there? Now what do? The first step says what? The base case. In the base case, we are testing for the position of each of these numbers here. The sum of the first term is 1. Hope you are aware. The sum of the first term is 1. The sum of the second term is 1 plus 2, which is what? 3. The sum of the third term is what? 1 plus 2 plus 3, which is what? 6. Just like that. If I have 4 here, what is the sum of the fourth term? I have to add 1 plus 2 plus 3 plus 4. So I'm testing for the position of the sum of each of these terms. Meaning that the first is that I'll bring out what? Base case. Abi? The base case. This is also called the basic step. But most textbooks use the word base what? Case. In the base case, we are testing for what? N equals to 1. Meaning the position of this. Here becomes what? Okay, let me start by putting it here. We say try. N equals to what? 1. Here becomes S1. Meaning that anywhere I see N, I'll put 1. So S1 means sum of the first term. What is the sum of the first term here? The answer is what? Is 1. If I'm to test for N equals to 2, it means that I will find what sum of what? The second term, which is S2 Abi, equals to 1 plus what? 2. But let's start with N equals to 1 first, which is S1. Sum of the first term is simply this one. Then equals to 1. On this other side here, anywhere I see N, I will then put what? Somebody. I'll put 1. That will give us what? 1 in brackets. 1 plus what? 1 over what? Over 2. 1 plus 1 is 2. 2 times 1 is what? Is 2. This becomes 2 over 2, which is same as what? 1. Have you noticed that the left-hand side is equal to the right-hand side? What we have here when N is 1 is equal to 1. Then what we find that as the sum of the first term when n is 1 is still what? 1. Since the left hand side equals the right hand side, we can say therefore n equals to 1 is what? Is true. Is what? Is true. The next one is to try. I will just try n equals to what? 2. I can just try n equals to 2. Meaning that will give us what? S2. But most of the times, you don't need to continue with this. Once you can get n equals to 1, you can continue. But for the sake of my teaching, I have to just explain further for you guys to understand proper. So for s equals to what? N equals to what? 2. Our S2 becomes what? What do you think will be the sum of the second term? 1 plus 2. Yeah, we have 1 plus what? 2. All equals to what? On this side there, anywhere I see n, I will now put 2 now. Here becomes what? 2 times 2 plus 1 over what? Over 2. So our S2 becomes 1 plus 2 is 3 equals to what? What is 2 plus 1? That is 3, right? Let us cancel 2, can cancel 2 from here, right? Remaining 2 plus 1. What do we have here? We have 3. What do you notice? The left hand side equals the right hand side. Since they are both equal, that means that n is equals to what? 2 is also what? 3. I am done with the base case. I can continue with n equals to 3, the same thing. For n equals to 3, that means I'll use S3, Abi. Yeah, I will sum up 1 plus 2 plus 3. Then on this side, I will replace what? I'm going to replace my, what's it called? My n with what? With 3, right? With 3. Okay, now let's proceed further. The next step is what? The inductive. Inductive what? Steps. Take note. Mathematical induction, we attend the exam. That one is a must. You must always sit in the exam. So I want you guys to please take note. After solving this example, I will solve one more example, okay? Then we'll go into other topics and all that. Like I say, we are solving randomly, past questions and the rest. Okay. So inductive steps. In the inductive step, we say we are testing for 2 things, right? N equals to k and what? N equals to k plus 1. So I'll say try n equals to what? K. The concept behind n equals to k is that it might be true for n equals to 1. It might be true for what? N equals to 2. Or n equals to 3. Or n equals to 4. Okay? But might not be true for n equals to what? K, the last term. Even if it is true for n equals to k, to validate that it is true for all terms, I have to test n equals to k plus 1 after testing for what? K. Is that clear? So let's test for what? N equals to k. Meaning from this expression, anywhere I see n, I'll put what? K. That will then give us what? Sk. Sk becomes what? It means I will repeat all of this here. Because for k, k means everything here is k. That will give us 1 plus 2 plus what? 3 plus dot 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 plus n plus k rather. Okay. Dot 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 plus k all equals to k in brackets k plus 1 all over what? 2. K plus 1 over 2. This is called equation what? 1. This is called equation what? 1. All right. Now let's test for, let's try n equals to what? K plus 1. This is for Sk. Let's find n equals to k plus 1. Because in inductive step, we are testing for 2 things. We have done this. Now let's come back to this. Please, if you are following, indicate in the comment section that you are following. If you are following, please indicate that you are following. If you are following, please indicate that you are following. Let me clean here so that I can be able to solve for what? n equals to what? K plus 1. Now listen. For n equals to k plus 1, for this, that will give us what? Sk, right? Plus 1 equals to, now this is where you have to pay attention. To prove for this, sk plus 1, it means I will repeat what first? Sk. I will repeat when n equals to k, which will then give us what here? We're going to have here 1 plus what? 2 plus what? 3 plus dot plus what? K. Please pay attention. This is our sk, right? Sk means 1 plus 2 plus 3 plus that dot k, right? Equals to this. Then to find sk plus 1 means I have to repeat sk first. I have to repeat when n equals to 1 first, k, right? Which is what I've done. Then plus. Then for that n equals k plus 1, the next term will then be what? Plus k plus 1. All equals to what? Okay, let me repeat. I think I've cleaned the question itself. Some of you will be confused now. Let me repeat the question again. Question says 1 plus 2 abi Sn equals 1 plus 2 plus 3 plus dot plus what? N equals n plus 1 over 2. Let me repeat that. Now listen, let me repeat it again. I said to bring out sk plus 1 when n equals k plus 1. The rule says, it's a principle. It says repeat this first, which I've done, right? Then plus, anywhere I see n, I will now put what? K plus 1. I've done this, right? Here we have n here. Then the next term will now be what? K plus 1. All equals to, on this side here, we have what? K plus 1 times k plus 1 all over what? Somebody 2. Let me explain again. We repeated this first, abi, n equals to what? K. To find, we are trying for n equals to what? K plus 1. The rule says repeat what first? N equals to k. Are you there? Then anything you have here will be used to form this. If I have k square, for instance, here, I'm assuming if here is k square, what we succeed this will be what? K plus 1 all what? All squared. That is the rule here. Then for this other expression here, since I only have k, it means I will now replace this my k here with what here? K plus 1. If I have k cubed, let's say here n as what? K cubed. Meaning what do we do first? Is to repeat n equals to k, right? Then the succeeding term after this will now be what? K plus 1 always per what? 3. That's the rule. But because we have just only k, or just only n to the power of 1, abi, that means I'm going to repeat. After bringing out our n equals to k, then I will repeat this by replacing our k with what? With k plus what? 1. Is that clear? All equals to. Then on this side, anywhere I see n, I will then put what? K plus 1 times k plus 1 plus 1, abi, divided by what? 2. I repeat again. For this other side, my n is what? K plus 1. Bracket, what's our n again? K plus 1. We have 1 here already, right? Which is this one here, divided by what? 2. So let's evaluate further. So sk plus 1 is equals to 1 plus 2 plus 3 plus plus k plus what? K plus 1 equal to what? K plus 1 times K plus 1 plus 1 is 2. All divided by what? 2. We are heading somewhere. This we call equation what? 2. Don't forget that this is our equation 1, right? Okay. What do we notice here? I will then put, this is equation 1, right? I will then put equation 1 into equation 1, 2. Meaning, from this region here, 1 plus 2 plus 3 plus ... k is the same thing we have here, right? Right there? And we are told that the whole of this here, the whole of this is equals to k times k plus 1 over 2. Meaning that I can replace the whole of this with the whole of this here with this. Exactly. I repeat again. From here to here is the same thing with this, Abi, which is equals to this, right? So I want to replace this now, the whole of this with this, from here to here. So that means I'm putting equation 1 into equation what? 2. That will then give us what? Sk plus 1 equals, from here to here, what do we have again? The result here is what? Is k in brackets. K plus 1 over what? 2. It means I've replaced this now with this because we are told that the whole of this is equals to this. So I'm replacing this now with this, Abi. We are now left with what? Plus what? K plus what? 1. Which is equals to what? Which is equals to what? K plus 1 times K plus 2 divided by what here? By 2. Okay. Now the next thing we need to do is to keep on evaluating. If you look at these two here, there's a plus sign here, right? That separated these two terms together. And if you look at this, we have k plus 1, k plus 1. I can factorize this here. I can bring out what? My k plus 1 in brackets. All right? K plus 1 is common here. If k plus 1 is common, what will remain here is what? Is k over 2. Why? Because if we factor out k plus 1 and bring it out, when you divide the whole of this with k plus 1, we are left with what? K over 2. Plus, divide k plus 1 with k plus 1, we are left with what? 1. The reason because, even if I'm to expand this again, I'll come back to this. K over 2 times k plus 1 is still same as this. 1 times k plus 1 is same as what? K plus 1. All equals to what here? What do we have here? We have k plus 1 times k plus 2, all divided by what? By 2. From here, k plus 1 can cancel what? K plus 1. We are left with what here? We are left with k over 2 plus what? 1 equals to what? K plus 2 over what? Over 2. Let's see how we can evaluate this. Between these two, what is the LCM here? Is 2. 2 into 2 is 1. 1 times k is what? Is k. 2 into 1 is 2. 2 times 1 is what? Is 2. All equals to what? K plus 2 over what? Over 2. What do you notice here? The left-hand side equals to what? The right-hand side. So we have proved. Since our left-hand side equals what? Right-hand side. This shows that the expression above, the expression, meaning, which is this, right? Above is 2 for all natural numbers. is true for all natural numbers. So this is the solution to this question. I will solve one more example. Okay, then we'll move to something else. Let's solve one more example. I know this can be complex a little, but just try and go through all the lectures again. Try and go through all the lectures again. Try and go through all the lectures again. Okay. Let's solve one more example from your past question. This question will appear. Mathematical induction is something you cannot do without in the exam. I am so certain that IMSU must have to repeat mathematical what? Induction. They must have to repeat mathematical induction. It is a must. So please take note. Example 2. This time around, I believe that you have gotten the first knowledge. So, okay. Let's solve. This one we just solved now is also past question. That should be 2020. Let's solve another year of mathematical induction. This example we just solved appears in 2 years. It appears 2021, appears 2020. Let's look at that of. It also appears, I guess, 2019. Okay, 2019, not 2020. Okay, let me look for another powerful example. Let's solve this question. I've seen one already. Show by mathematical induction that no need of writing this, let me just put it because the board is too small, that sum, that Sn equals 1 squared plus 2 squared plus ... plus n squared equals n over 6 times n plus 1 times 2n plus 1. 2n plus 1. Solution to this. Now we have gotten the basic knowledge. The first step is called the base case, Abi. In the base case, I will just test for n equals to 1, then we'll move on to inductive step. If you can test for n equals to 1 alone, is okay for base case. You must not test for 2, 3, and 4, okay? So let's go. For n equals to 1, what do you have here? S1 equals to what? The sum of the first term here is 1 square, and 1 square is 1, right? Equals to, on this side here, anywhere I see n, I'll put what? 1, meaning 1 over 6 times 1 plus 1 times 2 times 1 plus what? 1. So S1 is equals to 1 equals to, here we have 1 over 6 times 1 plus 1 is 2 times 2 times 1 is 2 plus 1 is 3. So 2 times 3. So here we have here to be S1 equals 1 equals 2 times 3 is 6. Divide this 6 by 6. What do you have here is 1. So since the left hand side equals what? The right hand side, right? It means that n equals to 1 is what? Is 2. So I'm done with the base case. Let's now go into the inductive steps. You can as well try n equals to 2, Abi. That will give us what here? S2 equals 1 squared plus what? 2 squared equals to what here? 2 over 6. Is that clear? 2 over 6. Here we have 2 plus 1 times 2 times 2 plus 1, Abi. I'm replacing my n with what? With 2. Here we have what? Yeah, 1 square is 1, 2 square is 4, equals to what? 2 over 6 times 2 plus 1 is 3 times 2 times 2 is 4 plus 1 we have what? 5. So here look at this, 2 times 3 is 6, Abi. Okay, that same 6 divided by 6 will give us what? 1. So this can go with this. We are left with what? 5. What's 1 plus 4 is 5. 5 equals to what? 5. That means that n equals to 2 is also what? True. So the best case is true for both n equals to 1 and what? Equals to 2. Now let's go into inductive step. Please, I have to clean here for the inductive step. Now listen. For the inductive steps, we are testing for what first? N equals to k. Meaning I will replace my n with k. That will give us what? Sk equals 1 square plus what? 2 square plus dot 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 plus what will be here? K squared, right? Equals to what here? We have k over 6 times k plus 1 times 2k plus 1. This is our equation 1, right? Equation 1. Don't forget. The first one we saw for n equals to k is equation 1. So the next is to try what? N equals to what? K plus 1. Now I have already taught you guys this. To find n equals to k plus 1, what do we do first? Is to repeat everything here, right? Are you there? I have to bring out what? N equals to k, meaning for n equals k plus 1, sk plus 1 will then be, I will repeat n equals to k first, which is 1 square plus what? 2 square plus what? Dot 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 plus k square. Abi? Then the next time it will now be what? K plus 1. But because I have square here, there will be what? K plus 1, all what? All squared. Are you there? Then equals to, on this side, anywhere I see n, I will now put what? K plus 1. That will then give us what? Let's continue. We're going to have what here? K plus 1 over 6 times k plus 1 plus 1. N is k plus 1. Then we have plus 1, right? Okay. Multiply with 2 in brackets. K plus 1 plus 1. Let's evaluate this further and see what we are going to have at the end of the day. So sk plus 1 is 1 square plus 2 square plus dot 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 plus what? K square plus what? Here we have our k plus 1 all square, which is this, right? Equals to what? K plus 1 over 6. Here we have 1 plus 1 is 2. We have k plus what? 2. K plus 2, right? In bracket again. Here I can expand this. 2 bracket k plus 1. 2 times k is what? 2k. 2 times 1 is what here? Plus 2. Is that clear? I have to expand this. I multiply all these brackets here with this factor 2. And that gives us this. But we have what here again? Plus 1. Don't forget. Okay? So let's evaluate it finally. sk plus 1 equals to what? 1 square plus what? 2 square plus dot 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 plus k square plus k plus 1 all squared equals to what? K plus 1 over 6 times k plus 2 times 2k plus 2 plus 1 is what? Is 3. This is my equation what? 2. Are you guys following? Now, the same thing we did for the first equation will be repeated here. I'm going to put equation what? 1 into equation what? 2. Meaning that, you know, from here to here, from 1 square to k square is same thing with from 1 square to k square. And from here to here is equal to this. That means I will replace this here. Since this is equals to this, I can replace this with this expression here. So what is the right word here? Put equation 1 into equation 2. So I'm going to replace from 1 square to k square with this. Abi, now let's go. What will that give us? That will give us what? Yeah? And we have what? From here to here is simply k over what? Over 6 in brackets k plus 1 times 2k plus 1. We are done, right? I've replaced this now with this. After replacing this with this, we are left with what here? Plus k plus what? Plus 1, all what? All squared. All equals to what? K plus 1 over 6 times k plus 2 times 2k plus what? 3. Please go through this and see. I hope you are following, guys. If you have any question, please, you can ask. Hope you are following, guys. Can I continue? Okay, someone say, right on, sir. So that means I can continue. Let's finish up this. Please take note. Let's finish up. We are almost rounding up with this. Okay. This is where we stop, right? If you look at this, there's something common between these two terms. I have a plus sign here, don't forget. Between this and this, what is common is what? Is k plus 1. I can factor out k plus 1 out this way. If k plus 1 is common between these two terms here, what will remain here is what? Is simply k over 6. When you divide this now with this, it will remain k over 6. Since we divide this, right, the whole of this with this, we are left what? K over 6 times what again? Times 2k k plus what? Plus 1. Then plus, since if I should multiply this now with this here, I will come back to this. If you multiply k plus 1 with k plus 1, that was k plus 1 squared. So we have to factorize out what? K plus 1. Then equal to what? K plus 1 over 6, right? Times what? K 2. Times what? 2k plus 1, 3. K plus 1 can cancel k plus 1 from here. We are now left with what? K over 6 in brackets. 2k plus 1. Plus what? K plus 1. All equals to what? K plus, okay, here we have 1, Abi. 1 over 6 times k plus 2 times what? 2k plus 3. Are you there? And let's see what we are going to have at the end of the day. Let's multiply out this. K over 6 times 2k will give us what? 2k squared over what? 6. K over 6 times 1 will give us what? K over what? 6. Then plus k plus 1. This over 1, Abi. All equals to what? Here we have k plus 2 times 2k plus 3 all over what? 6. 1 over 6 times this will give us this. The next is to find the LCM between these three. What's the LCM here? It's 6. Divide 6 by 6, we have what? 1, abi? 1 times 2k squared is what? Is 2k squared. Divide 6 by 6, we have what? 1. 1 times k is what? Is 3k. Plus. Divide 6 by 1, we have 6. Multiply 6 by k plus 1, give us 6k plus 6. Let me explain. When you divide 6 by 6 is 1. 1 times 2k squared is 2k squared. Divide 6 by 6 is what? 1. That 1 times k is what? Is k. Then divide 6 by this one is 6. 6 times, you have 6 times k plus 1, abi? What is 6 times k? Is 6k. What is 6 times 1 is 6. Are you seeing the concept here? Okay. All equals to what? Let's expand. K times 2k will give us what? 2k squared. K times 3 will give us what? Give us 3k, right? Okay, let's finish up. K times 2k is 2k squared. K times 3k is what? K times 3 is 3k. 2 times 2k is what? Is 4k. 2 times 3 is what here? Is 6. Is that clear? All over what here? 6. Let's take if our answer will correspond. All we are looking for is that the left hand side must be equal to what? The right hand side, right? Let's find out if it is true here. Here we have 2k squared plus k plus 6k is what? 7k plus what here? 6 over what? 6, right? All equals to what? We have 2k squared plus 3k plus 4k is also what? 7k plus what? 6 over what? Somebody over 6. What do you notice here? That the left hand side equals what? The right hand side. So since the right hand side equals what? The left hand side. Therefore, the equation above, that means the original equation above, is true for all what? Natural what? Natural numbers. It is true for all natural numbers. This is just all about mathematical induction. Next question. Okay. I think this is the most complex question so far IMSU have ever set throughout these years. In math induction, this is the most complex. This particular example we just solved. Please, if you are following, indicate that you are following. If you are following, please indicate that you are following. Oh, I'm so sorry for that. Is the board clear now? Please, is the board clear now? Is the board clear now? But hope what I solved is clear. Hope you guys understand what I just solved now. Hope what we solved is clear, Daddy. Hope you understand what I just did. Eh? Please, I need your comments. I need your comments in the comment section. I guess we are going to stop now and possibly continue tomorrow. Okay, because of my battery capacity and the rest. But please, you guys should take note that we have class tomorrow. Tomorrow's class, we are having physics class tomorrow. Physics 101 at the tutorial center tomorrow. Please don't forget, by 10 a.m. Let's say, what is the time now? I think we have to end this class now so that we can all rest. For those that will be coming for tomorrow's class, so they can have enough energy to attend tomorrow's class. But after tomorrow's class, in the evening, I will continue with physics, because I was told that your exam, for those of you who attend Imo State University, that your exam will be starting on Tuesday, your major exam, which is physics and mathematics and biology, right? So that means that tonight we'll be converging again online for physics 101. This time around, I'll be more direct and more precise on what you should expect in your exam. All right? So please, I think I have to stop now so we can have a little rest. Thank you guys for coming online. And like I said, if you have any topic you want us to teach rather, online, bring them up. That's why we are all here to learn. All right? So to some persons, they might not be having challenges in mathematical induction. Okay, but for those of you that have some other challenges in some topics, or in mathematics, or any topic, even chemistry, bring them up. Okay, indicate those topics in the comment section. So in my next class, I can go through those topics and look at how I can talk on them and all that. Are you guys following now? So tomorrow morning by 10 a.m. we meet at Imo Tutorial College. So see you guys tomorrow in class. Okay, I have to stop now so we can have time for tomorrow's class. Thank you guys. Thank you.